Okay, guys, I'll try to explain the rationale of confidence interval uh, through this software. It's hard to write on it, but anyway. So suppose I might ask a lot of people, actually everyone in WMNU, which is about 3,700 people, how much they like psychology as a major. From one, that's the worst major, to five, that's the best major. And because there are so many people, so we just treat it as a population. So we can get all the data and do a histogram, and hopefully it looks pretty much like this, right? And suppose we know the mean already. We know the mean is 3. So population is mean. Mu is 3. And sigma, which is the population's standard deviation, is 1.2. Okay. Now, suppose we can gather data, actually sample of 9. From randomly pick up 9 people from this population, calculate the mean and put it back, and then take another 9 people, calculate the mean, put it back, and so on and so forth. Repeat it so many times. Then we'll have a mean distribution, right? We just discuss about that. Now let me try to draw this. So hopefully the distribution looks like this. Oh my goodness. Okay, here. Ooh. Because it becomes more narrow and more normal. Okay, so don't criticize my drawing skill. This is so hard to write mouse. But anyway, so this is distribution of means, right? And the mean of this distribution, we call it mu sub m, right? Remember? And it will still be 3, right? Now, how about the uh, standard deviation of this distribution? First, we call it standard error. Okay, actually, let me write it. Okay, we call it standard error, right? Standard error. And how do we calculate the standard error? Um, uh, the very smart statistician tells us that this is the formula, right? When sigma is population standard deviation, and divided by the square root of sample size, which is 9, right? So let's calculate that. So it should be sigma is 1.2 divided by the square root of 9, which is 3. So it becomes 0.4. All right. So this is standard error, right? In other words, the standard deviation of this distribution. Okay. Okay. Now, this distribution is very important for us because in many cases we don't know the true mean of the population. So if we can know this distribution, then we know, hey, at least approximately the true population mean falls within this range. Because this is the distribution of means, right? Now, recall when we discussed a normal distribution in the z-scores in the z-table, right? And we discussed if we want to know the z-score and the associated area, we check the z-table. And remember, we said 95% around the mean. This is 95%. So if it is 95% around the mean, the z-score associated with it will be 1.96, right? Or negative 1.96. Yeah, remember these two numbers. Now, if you don't know what I'm talking about, you need to go back and review my previous video, okay? So now, move back to this one. You see, this is the distribution. And this is 95%, this is 1.96 right here, or negative 1.96 of z-scores right here. So if we want to know the range, all we need to do is convert this 1.96, the z-score, into the raw score, which is not so hard to do because we already know the formula of z-score, right? Remember that the formula is okay. I guess I need to write again. Do I need to write? Yeah, let's see. Z equals x. Well, actually, so x, which is the raw score, minus the mean, and then divided by standard deviation, right? Now, for this distribution, we know the z-score already here. All we need to do is just convert the z-score to raw score. So what is that? Z-score is, let's calculate this score first. So it's 1.96, right? Equals, we don't know m. No, sorry, we don't know this raw score x, but we know m. What is the mean for this distribution? Oh, it's 3, right? So let's write down 3. Then divided by standard deviation of this distribution, which is actually the standard error, which is what we just calculated, 0.4. So 0.4. Now, from this, we should know how to calculate x, right? So, okay, let me show you this. So we need to get rid of 0.4. So we need to times 0.4 on both sides of this formula. So 0.4 times 1.96. Oh, sorry, 6 equals x minus 3. So the number here you can calculate, but I guess it's about 0.78. Yeah, if I remember right, which is x minus 3. And now let's get rid of the 3. So 3 plus 0.78 equals x minus 3 plus 3. Okay, so now this will cancel out, so only x, right? And this plus together is 3.78, which equals to x. So we know that now this here is 3.78. Okay, now how do we calculate this? It's the same thing, right? So negative 1.96 equals x minus 3 divided by 0.4. And then you can calculate that, okay? I'm too lazy to do that. I think you should be able to do that already. All right. So the point is, if we know this distribution, we know the range that the true population 95% of the time falls within. And that's really useful, okay? Now come back to this formula. You can use my formula, the way I do it, or you can take a look at the book, which I'll show you later, okay, in the later video. But what's important is you understand how to do that, where it comes from.